Hello everyone. Hey students, this is Algebra Made Simple. Welcome to another video. Today we're going to talk about how to add and subtract polynomials. We're going to talk about how to classify polynomials, and we're also going to talk about how to multiply polynomials. This is a big topic, a big content area in the Algebra 1 curriculum. But of course, you're going to see it in Algebra 2 because algebra and math build on themselves, so you never really escape it. This is going to be helpful no matter what level of algebra you're in. So let's go ahead and get into a few examples, and then we'll work through them together and hopefully make a little more sense to you guys, okay? So we got 3 examples. I'm going to start with number 1. This is an example of 2 polynomials that are being added to one another. Now, if you're taking the Algebra Made Simple course and you're going over the topic of classification of polynomials, notice that each one of these in the parentheses has 3 terms, okay? Do you remember what we call a 3-term polynomial? That's right, that's called a trinomial. Tri meaning 3, nomial is kind of like a reference to how many terms, trinomial. And notice that degree right there is 2. The highest degree that you see is 2, so we call that a quadratic trinomial. So what we have here are 2 quadratic trinomials being added together. Now the thing you need to realize is when you're adding, see that plus sign? It doesn't matter if you're adding or subtracting. So when we look at example 2, you'll see that too. Excuse me, fighting a bit of a cold here. But when you're adding 2 polynomials, you simply find the degrees, the terms that have the same degree. So in this case, we have 3x to the second plus, you consider that a 1x to the second when it's like that. We're going to add them together, and they're considered like terms. So 3 plus 1 is 4. So I'm going to write that as 4x. And we're going to keep it to the second power, which is different when you multiply. We'll get into that in a minute. So we got the x squareds. They came together, and we added them, and that became 4x squared. We're done with the x squareds. Now, and I'm just going to put a little box around the other one, okay? Now you got that negative 3x and the positive 3x over here. So the ones that are alike as far as the variable to the first power, we put them together. Well, negative 3 plus 3 cancels out. I mean, that basically equals 0x. So you might as well not even put it. I'm just going to put a little x on those. In other words, you're gone. And then lastly, you got the constants, the 4 and the minus 6. They don't have variables. 4 plus a negative 6 is minus 2. And so there you have it. The answer would be 4 squared minus 2. So it just turns out this is a 2-termer, our final answer that is, and we call that a binomial if it is a 2-term, and it is a degree of 2 as well, so that's a quadratic binomial, okay? So that's just how we do adding of polynomials, okay? So we're going to do it again with subtraction. This time I'm not going to circle stuff. I might just underline it. So you got the x squareds. Go ahead and zone in on those. This is 2x squared minus 1x squared. Well, 2 minus 1 is 1. You could say 1 in front of that x squared, but usually you're just going to see it just listed like that, x squared. You know, you could have a little 1 there. Sometimes people will put that there, but most of the time they will not. 2 take away 1 is 1x squared. Now we're going to look at the x's. You got a negative 2x minus, now watch this. This is where kids get confused. That's negative 2 minus, see that minus in the middle of the parentheses? Minus the 5x. So negative 2 minus the 5x is a negative 7x. Okay? I know it's a positive 5x, but you have to look at it like you're subtracting 5 from it. So negative 2 take away 5 is negative 7. And now we have the constants 3 take away. Now watch this. This is where other people get confused. Negative, negative. You have double negatives occurring there. You have a minus sign and a negative inside the parenthesis. So 3 take away a negative 5 is the same thing as a positive. Okay, it's like a double negative makes a positive. So you have to look at that as 3 plus 5 when that happens, and that can be a cause of confusion for many kids. So watch for it. Minus and negative really means plus. So here's what we got here. This is 3 terms. We call that a trinomial. Degree is 2, quadratic trinomial, and that's our answer. Okay. The subtraction can be a bit tricky if the negative stuff messes with your mind. So watch this video as many times as you need to help you minimize that confusion. Okay, so when it comes to number 3 here, I'm going to circle number 3 so you guys can zero in on it. I'm probably going to do that on my trusty whiteboard. This is a digital whiteboard, but I actually have a physical, old school, like, kindergarten whiteboard. I'm going to write these down, and I'm going to do this without the share screen, okay? Just because I think it's easier for me to point out some stuff. Oops. Almost knocked over my microphone. Okay, so for this last part, I'm going to switch the screen back. Hopefully you can see me nice and good here. All right. So this is the first example where you don't have adding polynomials or subtracting polynomials. You have multiplication of polynomials. Hopefully you can see that all right. Okay. So what you have here, you have is a monomial, 8p, and it's being multiplied by the trinomial inside the parenthesis. Now hopefully you've learned this in the past, but if not, this is your lesson now. Anytime in algebra, you might as well get used to it. Anytime in algebra you see a term on the outside of parentheses, know that you're supposed to multiply it to everything inside the parentheses. We call that distribution, okay? So what I like to do is I like to draw arrows. So I'm going to do 8p times the 2p squared. Can you see that? We're going to multiply that out. Now here's the deal. It's different with multiplication. Hear me out. Even though you're not going to see it written there, you have my permission to pencil in a little 1 over the p's. You see how I just put a little power of 1 there where the p was? 8p became 8p to the first power. Anytime you have a variable and you don't see an exponent, it's understood that the power is 1. Why do I say that? The reason is, now listen to me here, when you multiply polynomials, when you multiply terms, you have to add the powers. That's a little trick, okay? So what do I mean by that? So you see 8p times 2p to the second. Well, the coefficients multiply like they normally would. 8 times 2 is 16, of course. But the 8 had a p and the 2 has a p squared. Well, you add the powers when you multiply the coefficients. So 1 plus 2 is 3. You can see that okay. So this is going to become 16p to the third power, okay? That's my first multiplication step, okay? You keep the base p, but the exponents get added up, okay? So we're going to do that with every single one. Now we're going to take that same 8p, I like to draw arrows, and multiply it times the middle term, 2p to the first power. So once again, 8 times 2 is 16, but notice you have an exponent of 1 here, and you have another exponent of 1 right there. Sorry for the glare. So that's going to become 16p to the second power. So we're going to say plus 16p squared, or 16p to the second power. Okay? Kept the base p, but I added up the exponents. One more, I got to do the same 8p, and I got to multiply it by the constant at the end, the negative 2. Notice that one doesn't have a p, so we're just going to do 8 times negative 2, which is negative 16. But since 8 had a p, we have to include that p in our answer. So the final one is going to be negative 16 or minus 16p, just 1p like this. Okay? And we're done. So the key idea here is go ahead and multiply the coefficients, which are the large numbers in front of the variable. Multiply them like you normally would. But the powers, when you multiply those terms, you add them up. Okay? You add them up. All right, there's one more example I want to show you in case you have never seen one of these before, and it's called a binomial times a binomial, and you'll usually see them in 2 parentheses side by side. So let me jot this last example down here, and then we'll end it on this note. Okay? All right, I got it on my paper or on my board. Check this out. So this is one that you'll see a lot in Algebra 1 and Algebra 2 over the time and months that you're in those courses. And so the way you want to do this is keep it simple. You know, this is algebra made simple. I always tell people you want to take each term in the first parenthesis and multiply it by each term in the other parenthesis. Okay, so what do I mean by that? I start with k, and I'm going to multiply the k times the 6k in the other parenthesis, but I'm also going to multiply it by the negative 2 in the other parenthesis. That's why I did 2 arrows kind of coming out of the k, if you can see that. So let's start with the first one. K times 6k is just going to be 6k to the second power. Keep in mind, even though you don't see it, each of those k's is to the first power. If you see a variable, you have to assume the power is 1. Okay? So k times 6k is 6k squared, or 6k to the second power. Then I'm going to take the same k and multiply it by the minus 2. K times negative 2 is minus 2k. Okay, so there I go. I'm done with the first k. I multiplied this k times this and this, both terms. So I'm going to not underline it. Now I'm going to underline the 7, just so you know. Now we're going to take the 7 and we're going to multiply it by both terms as well. I like to draw the arrows underneath when I get to that second term. So I'm going to do 7 times 6k. See that little arrow I did there? Doing the 7 times 6k. 7 times 6 is 42. And since 6 had a k, we're going to say 42k. So we'll say plus 42k. And then that same 7, let's do another arrow. That same 7 gets multiplied by the minus 2. So 7 times minus 2 is negative 14, or minus 14. So here's what we have left. We have done all the multiplication. But are we finished? Well, not really, because we like our final polynomial to be what's called simplified. Right now we have 4 terms. We're done multiplying. But if you notice, these 2 terms in the middle are like terms. They both have a k. That's 2k minus 2k and 42k. They can be combined into one term. All right? So negative 2 plus 42 equals 40. So instead of leaving it as 2 terms, I'm just going to combine them together, and I'll just bring down everything else that I haven't really used here. Okay? Oops. Knocking into stuff. So here's my final answer, this bottom row. It's a quadratic trinomial. We have a term of each. We have a k squared term. We have one that's just k to the first, and we have a constant. Okay? If you got 2 of the same type of term, these are both k to the first, that means they could be combined together. At this point, I just did addition and subtraction, okay? The only time I multiply is at the beginning when the arrows are coming out. So I don't have to add the powers when I'm adding or subtracting. I only add the powers when you're multiplying terms. I cannot emphasize that enough. You only add the exponents, add the powers, if you're multiplying or distributing the terms. If you're adding terms together, you just keep them the same. You look at the powers, which ones are alike, combine them together. Is that helpful? Does that make sense? So hopefully if you're taking this course, you're going over how to classify, how to name polynomials based on how many terms it has, or the degree, which is the power of the highest term in your polynomial. But there's a little difference, a little nuanced difference there, depending on if you're adding or subtracting polynomials or multiplying them. So hopefully that was helpful. This is Algebra Made Simple. Keep it simple. I'll catch y'all in the next one, all right? Peace.